Hello everyone, it's Dr. Zach again. So what I want you to do today is review concepts related to derivatives. You are preparing for the optimization test and your midterm. So what I'd like you to do is complete the next 2 pages of your notes. Afterwards, check your answers on the video. So stop the video right now and complete several of your questions. Your lesson warm-up today was to remind you about your quotient rules. So the product rule and quotient rule, very important rules as you find derivatives. Now these can be done abstractly, as you can see, and then you're going to substitute and find the value for h prime of 7. Now when we look at question B, what you should notice is that you have a graph with limits. So limits will be on your midterm. Make certain that you understand that you can take limits from the left, limits from the right, and when a limit from the left equals the limit from the right, that limit should exist. If they have different answers, the limit does not exist. F at 1, for example, is touching the value. It does not exist. And then when you look at the left-hand endpoint, your graph is going upward, so it goes towards positive infinity. And when you look at your right-hand endpoint, your graph is also going upwards, so your function heads towards positive infinity. And once you are completed A and B, hopefully you read about linear approximation. This is one of those concepts that I am expecting you to be an expert at, linear approximation. And then you had a quick reminder about differentials. So 2 of the definitions that need to be in your mind from differentials are your propagated error and relative error. So let's look at the examples related to those. For example 1, you are asked to approximate the natural log of 3. So declare what your function would be, such as f of x equals natural log of x. Find the derivative. Find the value at e because you were told to use e. Then write the equation of your tangent line. So the equation of the tangent line should always have a number in for the slope. Do not ever put a variable expression in for the slope. Once you have the equation of the tangent line, you are ready to approximate the value f at 3. Use your approximation symbols and simplify to get 3 over e. So your answer is close to 1. The natural log of 3 is close to 1. Now for example 2, we were talking again about propagated error and relative error. To find the propagated error, you're going to use the differentials. Once you've set up your problem and knew that you were looking for the length of the side y, in this case, write your equation, find your derivative, understand propagated error means find dy. Now this part might have jumped out of your mind, so let's take a look. When you did your substitution, d theta was plus or minus 3 degrees, but you cannot multiply an expression by degrees without compensating by multiplying by pi over 180. Because remember, the change in y was supposed to be a length or feet, and in having degree feet, it doesn't make any sense. So you want to change it all into radian or multiplying by pi over 180. Not to be confused though, when you were looking for relative error, it was dy over your y value. So dy over y, and the y value, when you substitute in for sine of 30 degrees, you get 1/2. This does not make it a degree. That doesn't make sense. So just 8 times 1/2 is 4. So your relative error is dy over y, and propagated error is dy. So if you haven't already completed the lesson practice, stop the video right now, work on the lesson practice, and come back to check some answers. Okay, so once again, I have a sample for you of talking about relative error. For this sample, I found dA over A simplified and then substituted. Notice I don't put any units here because when you take area, which was RR over R squared, all of the units canceled out. For question number 2, once again, we're looking for the propagated error. You do need to know surface area of a sphere. So if you didn't have that in your list of things to know, put it there now. Question number 3, you were looking for linear approximation to think about 2.99. So I'm hoping you set f of x equal to x to the third, found f prime of x, then knew that f prime at 3 was 27, but f of 3 is also 27. So when you substitute that, you have y minus your 27 is your slope, that's your derivative at 3, and x minus the x value that you're using, which was 3. So your answer is close to 27, which makes sense, but it's a little bit smaller. For number 4, the fifth root of 33. So find f of x, f prime of x, f prime of 32, and substitute. So your answer is just a little bit more than 2. Number 5, I didn't complete for you, but what you need to know is that if your particle is speeding up, your velocity and acceleration have the same sign. So find x prime of t, x double prime of t, and make a table of values to determine which ones would be speeding up and which ones are slowing down. If the signs are the same, you're speeding up. If the signs are different, you're slowing down. Number 6, so this one, you were told that f is a function increasing for all values of x. It doesn't matter what's happening with g of negative x because f is always increasing. So once again, if you have not given these problems a try, stop the video and try them out for yourself. I want you to be particularly careful when you're stating whether you have a minimum or a maximum. Be very clear which test you are using and show the work for the test. So in this case, I use the second derivative test. I generally use the second derivative test as long as the second derivative is easy to find. Take a look at these problems if you would like. I've given you 4 different optimization problems to consider. Now, question number 10, you're minimizing your surface area given a volume for your function. And this volume for your function was not changing. So this is a more abstract problem and kind of fun. I also used the second derivative test to prove that you had a minimum. All right, so once again, your lesson follow-up, you are completing some questions to prepare for your midterm exam. You have to go through 1 through 8. As you look on the next page, notice that they are optional. So we have some optional practice here to help you prepare for optimization. If you have been doing a great job on your previous problems, then you do not have to complete this group. All right, that's it for today. You have a fabulous afternoon.